Greetings. Welcome to our 34th episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. On today's episode, we are going to focus in on our September 9th, 2021 webinar titled Industry Best Practices for Floating Cover Systems. I'd like to quickly reintroduce our webinar speakers. First is Brian Fraser. Brian is Vice President of Layfield Group, responsible for business development in the United States and internationally. Brian has been working in the geomembrane business for 41 consecutive years, including manufacturing, fabrication, testing, and construction. He's also written a number of technical papers on floating cover systems. Next is Doug Hiltz. Doug is the founder and president of Hiltz Consulting Group with more than 30 years experience throughout the United States and internationally. Doug is a recognized expert and specialist in the field of reservoir geomembrane floating covers and bottom liner systems. Our next speaker is Rohit Sati. Rohit is a technical product manager with the Layfield Group and a member of Layfield's Technical Services Group, and is the technical project manager responsible for geomembrane containment products. Rohit's been employed with Layfield for 16 years in various positions, including engineering business manager, technical sales support, and responsible for product development. The title of today's webinar presentation focus is Industry Best Practices for Floating Cover Systems. Brian, Doug, and Rohit, thanks for joining us again and squeezing this into your busy schedule. Joining us from Edmonton, Alberta, and Orange County, California. So we have a number of questions left over from our live webinar presentation that we did not get to, and also 6 questions from the post-webinar survey. So I'd like to jump right into these questions. There's many of them. So our first question is, does the geomembrane ever break down and show any chemical migration into the water that is being covered? So Rohit, could you cover that?
Sure, Tim. Thanks for the question. As you know, most of the attendees are aware, geomembrane has got 2 sides. I mean, the top side is usually exposed to the elements like UV and solar radiation, and then your bottom side is exposed to the fluid. So yes, I mean, you know, if your bottom side, which is exposed to you know, some of the potable water which contains chlorine and can have you know, flaking issues or degradation, clotting, etc. Yes, it will you know, degrade the overall quality of the water. But the top side, even if it's you know, slightly degraded, if you have some initial chalking happening on the material, you can fix the issue. But if it's the bottom part, definitely you will see that in the water quality.
Okay, next question. How long is the useful life of a floating cover system? And generally, what is the cost per square foot of the cover system? Brian, can you handle that?
Yeah, you know, certainly the life expectancy, project life will vary on application. You know, we have applications where people want covers under 10 years, more kind of on the energy sector. There's some owners that are comfortable with projects to 10 to 20 years, but in most of the municipal applications, you know, owners are looking for a 20 to 25 year life cycle. And you know, really the criteria to get to 20 years plus is you need to have a properly designed floating cover. You need to obviously make sure you have the right material selection. No different than a vehicle. You know, you need to have regular maintenance, at least every year, every second year, service and maintenance, doing any cover repair. And I think, you know, it's important that the owner of the floating cover, you know, does his or her due diligence, you know, just making sure all of that is done. And usually if those 3 variables are done, you know, we see a lot of covers that can do 20 years plus. Costs are you know, really vary. material cost versus installation cost, really hard one to peg, Tim, unless we know the application and design, can range substantially. So I'm probably not best to answer that one without, if anyone wanted to talk to me specifically, we could talk the application and I can give them some budgetary numbers.
Okay. And the next question is, do the panels come on pallets? Brian, can you answer that?
It come both way, Tim. Again, most of these materials for covers, we're working with a well-known flexible membrane liners. They can be prefabricated, folded. A lot of cover materials are rolled up at somewhere around 8-foot folds and palletized and packaged. There are more critical projects where engineers want to see longer rolls with no folds. Will produce panels 30 or 35 foot wide by custom lengths. Those again are properly packaged in long tubes. We call them cigar tubes, and those large panels can be shipped to site and deployed without any fabrication fold.
Okay, next question. What is the preferred number of plies or layers in a reinforced geomembrane? Doug, could you address that question?
Sure, thank you, Tim. I think really to adequately answer this question, it really depends on the application and what materials you're looking at and the longevity of the project, what the target lifespan is. Having said all that, I would say for reinforced geomembranes, generally 3 plies for reinforced geomembranes is probably the most common when it comes to reinforced floating covers.
Okay, next question. What are the most important physical properties for a reinforced geomembrane? Rohit, could you take that question?
Sure, Tim. I think from my standpoint, I think, I look at mechanical properties which are better compared to the unsupported geomembranes. You get both puncture and tensile properties, that are significantly better. But some of these advantages that you get from reinforced materials, also affect, some of the multi-axial properties. So as a designer, you got to look at the application and decide, what material you got to use.
Okay. But there are no physical properties that, just for example, tensile resistance, are there any that are really important?
As I said, tensile is definitely one of them. Tear resistance, the tear propagation with supported materials is definitely better because the scrim provides a resistance to stop the propagation of the tear. So yeah, both, as I said, mechanical properties. So tear, tensile, puncture. These are all good properties for reinforced materials.
Yeah. What about dimensional stability?
Definitely, the scrim. When you talk about thermal expansion and contraction, the scrim keeps the entire material together. So you see less stability issues, especially with regards to thermal expansion and contraction.
Right. Okay. Next question. For floating covers, what material has a better performance, reinforced or unreinforced geomembranes? Doug, why don't you start on that question, please?
Again, it kind of depends on the application and the desired lifespan of the project. Based on my experience, for most floating covers, and particularly for potable water floating covers, I think the preference is a reinforced geomembrane. I think it just offers a lot of advantages in terms of you mentioned dimensional stability, tensile strength, just tends to lay a little bit flatter. Flatter cover means less bonded rainwater, which is definitely a sign of a successfully designed and installed floating cover. So there are certain applications where unreinforced could be used, but I would say in general, reinforced is probably the material of choice, at least from my perspective. If we're talking about gas floating covers, again, I like the additional tensile strength, and therefore the reinforced floating covers or reinforced material would probably be my go-to material.
Right. Okay, next question. What is the advantage of an underground storage facility versus an open one with a floating cover? Brian?
Well, again, it's probably a little misleading, but a lot of our, say, drinking water is actually stored underground and around the world. And so, obviously, surface space, because we're not utilizing above ground construction, advantages with protection and security. So there are definite advantages. Probably a little bit on the cons. We do put a lot of geomembrane liners somewhere in the life cycle of underground storage because of cracking or heaving of the material. So we do need to waterproof these with geomembranes. There can be some access problems to get in and out of these as well. Again, it's certainly a mainstream way of storing water. Below ground reservoirs, above ground tanks, reservoirs with floating covers, all three methods are very common ways of storing treated water.
Okay. Brian, during the webinar, actually it was near the end, you showed a photo of the Hinkle Reservoir and mentioned it had been in service for almost 40 years. And you mentioned coupons being taken from the original material. And this question deals with, did those coupons, or how did those coupons compare to the original specifications for the geomembrane?
Yeah, Tim, I believe the owner of the Hinkle Reservoir has done a couple sets of coupons looking at the aging of the materials, which I think the covers have now been in. The cover's now been in place coming up on 42 years, and still seems to be functioning reasonably well. It is coming toward obviously the end of its life cycle, but there seems to be adequate strengths in there. Normally, again, I can't speak on behalf of the owner. It's confidential information. What I've seen on coupons that we've cut on covers at 20, 25, and 30 years of age, and it really depends again on the materials. There are certain materials, like CSPE that seem to age better in, say, potable water applications. And those materials, we typically see the tensiles holding close to spec, but we start to see some degradation in tear strengths. So there's a bit of give and take. Certainly as covers get up to their expected life expectancy, they should be tested for material strengths.
Okay. Next question. What is the maximum depth of the trough in the cover? Are troughs used to take up slack in the cover as well as collect rainwater? Also, is the depth of the trough limited for safety reasons in case someone falls into it? So Doug, if you could handle those questions, please.
Yeah, Tim. They kind of answered their own question, but yes, I'd confirm that troughs are used to take up slack generated in the floating cover as the water level fluctuates. But the troughs also provide tension that is then imparted on the floating cover that allows personnel to go out on the cover, do inspections, maintenance, and whatever else they may need to do out on the cover. And it also, because it is tension, then it promotes the removal of rainwater, surface water from the general field of the cover into the troughs. The troughs also serve as a mechanism to channel water, rainwater, to the rainwater removal pumps. So the troughs are a pretty essential and significant element when it comes to floating covers, and that they provide multiple functions. As in terms of the depth of the troughs, generally we look at about 6 feet as the maximum depth, and part of that was developed based on safety concerns and safety reasons. Although I will say, if you were to fall into a trough, it's not as though you would get swallowed up into the trough. I've actually tried to enter into a trough before, and it's very, very difficult because the hydrostatic pressure from the water on the bottom side of the floating cover. So it is for safety concerns, but it's not a significant safety concern, I guess, is from my experience. And I will say that there are areas, localized areas, where the depth of trough is greater than 6 feet and really doesn't pose much of a concern.
Okay. Next question. Do you construct a cable tension cover system when the reservoir is empty? Is it limited in depth to take up the slack? Doug?
With the cable tension floating cover, it can be installed empty or it can be installed in service. I think in the seminar, Brian had showed a video and some pictures of reservoirs where the cover was floated on. Has been done, can be done, just requires some additional coordination and thought process in terms of how the sequence of construction would be performed. My personal preference is, whether it be weight tensioned or cable tensioned, I prefer to have the covers installed in the dry, and that way I know that there's adequate slack installed throughout the entire operating range and even drained condition of the floating cover. In terms of the reservoir depth consideration, there isn't really a limit, although I will say for a cable tension floating cover, for all floating covers, the slack is generated at the bottom of slope as the water level rises. And with the cable tension floating cover, the slack is pulled up to the top of slope. So if you had a very deep reservoir with steep side slopes and a lot of slack being generated, and a reservoir that operated with a lot of fluctuation, keep in mind that that material is going to be pulled up and down slope continually as that water surface level varies.
Okay. Next question is, how weldable is CSPE, i.e. Hypalon, over say 10 years in a high UV exposure area? Rohit, could you answer that question?
Sure. Very interesting question. Now, from our experience, CSPE has been used in aggressive UV climates like in Arizona, South California, Australia, etc. And Hypalon has got this unique ability to cross-link, after it's being installed. And it goes from a thermoplastic phase into a thermoset phase, which basically improves, some of the mechanical properties of the material, namely the tensile strength. Now, there are definitely some small challenges with regards to weldability of this material after it has been exposed for over 10 years. But with some special cleaning agents, we can wipe off the aged surface and expose the surface underneath, and actually do either we can use some adhesives or we can use thermal welding techniques to weld the CSP material. We have done it, and if somebody is interested to know more about this, they can contact us through an email, and we'll be glad to answer their questions in greater detail.
Okay. Doesn't provision of troughs increase the chance of tear of the cover due to further puddling or ponding of water? Doug, another trough question for you.
The ponding of water, I guess I'll first address it from a weight tension floating cover perspective. The ponding of water and the trough formation really doesn't affect the tear potential. And when I say tear potential, I mean the material failing in a tear mode, not necessarily just a break of the membrane itself. I would say for a weight tension floating cover, what's probably more important would be any hard debris that were to enter into the trough that could pose a puncture potential. But all this supports the need for periodic floating cover maintenance and cleaning, and trying to remove any type of debris that could potentially puncture the floating cover, specifically in the troughs. When we talk about ponding of water for a cable system cover, as you add water on top of the cover, again, you're pulling that cover up and down slope incrementally, and some of the attachments can be harder attachments where the loads may be concentrated. But that's something that's all really accounted for in design when we design the tabs and the strengths of the parent floating cover material, the tabs, the cables, and the batten bars. So I think if it's properly designed, that tear mitigation or potential goes away.
Okay. Can there be designs which can reduce the amount of water puddling on the cover? Doug, if you can answer that one.
Yeah, I mean, the best way to reduce ponding of water is to limit the amount of incidental slack in the floating cover. And the incidental slack can come during installation. If you have a properly designed floating cover, you've anticipated where the slack is generated, and there's troughs installed to pull that. And ideally, you'd like to maintain the cover in a low tension state and laying in a flat plane right on top of the water. So it really just comes down to proper design and adequately tensioned floating covers. And if you meet all that criteria, you should see very little ponding of water.
Okay. Doug, another question for you regarding the floats and weights in the cover system. Do the floats actually assist with floating along the water trench / trough, or does it only assist with taking up slack and giving the cover system some rigidity?
The floats in that application, the floats actually aid in defining the trough. If you didn't have the floats, the trough would be more like a big open V, and it would be more difficult for personnel to approach the trough. So the troughs are important, or the floats are important because they help define the boundaries of the trough and create a trough that is more in a vertical orientation. But the floats also provide buoyancy to support the ballast, which tensions the floating cover. So we always provide more ballast than we have, or more flotation or buoyancy than we do in ballast to ensure that basically the cover remains floating.
Okay. Brian, what are the NPDES permit requirements for covered basins? More specifically, can floating covers be used to reduce NPDES outfall requirements?
I guess to answer that, the first word would be partially. I know of NPDES, we call it NPDES, and the National Pollutant Discharge Elimination System. And I'm more familiar with it, Tim, in terms of municipal secondary wastewater projects. So NPDES was a permitting program created back in the early 1970s by the Clean Water Act and EPA, and helps to address water pollution by regulating the point sources and pollutants. So they're really more concerned from the permitting point of view to make sure that the technology is going to, or the design is going to achieve the discharge requirements required by the Clean Water Act or the state regulatory requirements. Normally, it does not state the type of floating cover or geomembrane, or whether a cover or geomembrane should be used. They can be incorporated into the design, which is submitted into the NPDES permit. And what the permitting really requires is that you will meet the critical discharge requirements and reductions of things like biological oxygen demand, chemical oxygen demand, total suspended solids, et cetera, nitrogen, ammonia reduction. So again, we see it mostly in municipal secondary treatment. Doug may have seen it from time to time in the potable water side, but we see it in the wastewater side more with our modular or insulated cover systems.
Okay. Doug, another question for you. Does a floating cover system always touch the liquid underneath the cover? How do you handle precipitation on the floating cover? Collect and pump the precipitation water from the cover?
That really depends on the application, if it touches the liquid. In general, yes, but if you're talking about a gas collection cover, the cover does touch the liquid below in some cases, but not necessarily in all cases. I would say, absent of the exception of a gas collection cover, a properly designed floating cover should sit on top of the water surface and maintain that intimate contact with the pond contents or the water below. How to handle the precipitation on a floating cover. Again, I think I talked about that before. Collection troughs, tension troughs, collection troughs that collect the rainwater and channel that water to pumps. I would say the vast majority of floating covers have pump systems that remove the rainwater. And yeah, I think that's it.
Okay. Rohit, are PVC geomembranes a viable option for floating cover systems?
Well, I mean, if you're talking about a regular grade of PVC, like a standard PVC membrane, it may be suitable in a short-term application, but again, PVCs are not rated for extended UV exposures, and they'll basically disintegrate if they're if they're exposed to longer hours of sunlight. And also, they're not considered as the best material for potable water applications, primarily because of the odor issues. Now, there are some specialized PVC alloys that you see in the market that do have UV stability and also have eliminated the issue of odor. But again, I mean, to answer your question, I haven't really seen PVC geomembranes used in municipal water storage applications, but they may be used, as I said, in water wastewater applications, for a short-term duration.
Okay. Brian, what material are the floats made of, and how are they connected to the geomembrane of the cover? What is used for insulation for MIC covers? What temperatures are inside of ponds with MIC covers? Are there limits for prefabrication in terms of material thickness as the prefabricated cover needs to be transported and installed? So there's a bunch of questions there.
Yeah, I'll try to capture that, Tim. So we refer to them as modular insulated covers, or MIC covers, and typically, again, the foam is normally EPS, expanded polystyrene, and the thickness of the foam is really determined based on the insulative value we need to achieve for the lagoon and the treatment. That can change a bit by climate, whether in the northern US or Canada or in the central region. And we need to look at climatic conditions, making sure the engineers normally are trying to achieve, or the designers, a certain amount of temperature to maintain a reasonable bioactivity in the winter months. And normally the insulation is typically the thinnest 2 inches, quite common 3 and 4 inches. We do prefabricate most of these with either a linear low density polyethylene or an HDP odor skin. Typically quite common to have 40 mil. There are different suppliers out there with different ways of connecting these modular insulated panels through customized hardware or special lacing systems. And regardless of what you use, it is really important that these are able to stand up to heavy wind loads, because we normally are not anchoring the MIC panels around the perimeters through anchor trenches, or they're normally just tensioned with cable tension, so they are more prone to upper wind lift and tear out. So there are some experience and tricks you need to do to make sure that you are properly anchored from wind lift problems. So Again, more information can be obtained if you want to contact myself or Rohit or Doug on that, and we can share further information with you.
Okay, Doug, what is the advantage of attaching buoyant flotation laterals to the top of the gas cover as exposed to the bottom side of the cover? How does the top mounted floats help gas passage?
Well, most of your gas covers are going to have ballast tubes. And depending on the orientation of the ballast tubes, you would want some flotation to counteract the weight of the ballast tubes. Should that ballast want to go in the water and the material sit on the water. So floats on top of the cover would help define a trough, and it also allows for any surface water to be channeled into that trough. In this situation, topside floats would not aid in the gas removal, especially for a negative pressure gas cover. If we're talking about a negative pressure gas cover, you would want the floats on the underneath side of the cover. This way it props the cover up above the water surface, even under low pressures, and will aid in the gas collection from underneath the cover. So I think it really depends if you're looking for buoyancy or if you're looking for gas collection, whether you put the floats on the top or the bottom. A lot of covers I've been involved with will have a little of both.
Okay. Brian, do you always recommend non-accordion folded geomembranes for floating covers?
Not really, Tim. Again, I look at each project on a project by project basis, the application and the materials. Certainly some of the larger, more engineered, long-term portable covers, I know certainly Doug likes to see, and I agree with him, large prefabricated panels without folds. As a manufacturer, and I think within the industry, we certain materials we quite often like to make sure we limit the amount of folds and creases. They can at times, be a part of environmental stress cracking. We see a combination of folds and the disinfectants, whether it's chlorines or chloramines and UV, etc., can sometimes cause some stresses on the materials that we don't like to see, and some problems. A lot of that is a little bit more problematic with, call it the polyolefin family, the polyethylenes, polypropylenes, even some certain EIAs. So I guess that's one of the reasons we try to prevent deep folds in long-term potable water covers where we are dealing with chlorines as disinfectants, etc.
Okay. Rohit, what is the flammability of the floating cover system? If it is not in direct contact with liquid below, is flame spread a problem?
Well, I think a lot of people will agree that flammability is not one of the desirable properties in a floating cover material. Now, is a floating cover flame retardant? Not really. I think first of all, they're not tested for flame performance or flame spread like you see some of the other materials. By the way, some manufacturers do make geomembranes, that are flame retardant geomembrane materials, but then they use some specific fire retardant additives, that make the product flame retardant. But that also gives issues with regards to NSF testing. I mean, some of this testing that NSF does and some of the other regional equivalents, they want to extract whatever they can leach out from the geomembrane and then analyze it. And in most cases, I mean, if you have the F4 additives in your formulation, the likelihood of getting clearance from NSF is probably pretty low. So it's a property that's interesting, and definitely if it's not in direct contact with the liquid, these materials are combustible. All of the geomembranes that we work with are combustible. What that means is that if it's exposed to continuous flame source, it will continue to burn. But some of the materials, that have flame retardant in them will actually cease burning because of the FR additive. So I would say, if this is a property that's required, there has to be some research and development to be undertaken to develop a material with the top side FR and the bottom side, regular potable grade material. If this was in a municipal potable water application.
Okay. And Rohit, you mentioned NSF. You mean the National
Sanitation
Foundation, right?
Yeah, that's exactly right. It's the 61, which applies for drinking water components, and that test is very extensive, and it will actually test possibly all the chemicals that can potentially leach out from the material. Just making sure that your drinking water is safe for drinking, actually.
Okay. Brian, does the use of cable tension covers propagate the tear of the covers?
Well, just historically, Tim, our experience with doing these coming up on probably about 40 years, I really haven't seen much of a problem with that. It's certainly not been a chronic problem with the tensioning cable systems. They typically are designed to pull the tabs more in shear versus peel. The towers are typically on 6, 8, 10-foot centers, depending on the design. So we're pulling these on fairly frequent intervals. However, I do suggest, again, within any cover system, the reinforced edges and the tension tabs should be inspected at least every second year. If you're seeing any concerns with tearing or peels, that certain amount of repair maintenance is completed. But just historically, we've had very little problems with tear on these. But again, they do need to be designed properly with the proper strengths, etc.
Okay. So now I'd like to turn to the questions submitted after the live webinar. So these are the questions submitted during the post-webinar survey form. First, Rohit, can HDPE geomembranes be used for floating covers? Are there any issues with their lower flexibility?
Well, I think it's also very application specific. As I said during the webinar, designers definitely look at fatigue performance because some of these materials, especially if your application has water level fluctuations within the pond, you will see a lot of movement in the cover systems. And if it's more of a static cover where you don't experience much of the movement, then HDPE might be a good choice. But if you have some of these movement challenges within your system, I would definitely look at more flexible material.
Okay. Brian, have you ever used aeration equipment for sewage lagoons underneath a floating cover system?
We have, Tim, certainly ground mounted or below cover aeration systems and diffuser systems are reasonably common actually in these municipal secondary aerobic wastewater treatment systems that we're using the modular insulated cover systems, as well as anaerobic gas covers. So commonly we have air through aeration and diffusers below. If these are fully sealed cover systems and they have to install proper ventilation, the MIC panels aren't designed that way. They're just connected. So, we will get air just passing through the standard panel intervals, but yeah, very common in secondary treatment.
Okay. Doug, is there a practical size limit, maximum number of acres, beyond which a floating cover becomes impractical or not feasible?
I think that largely depends on the application, coupled with the material strength and probably also the design loading. I will say this, the largest known in-service potable water reservoir floating cover, single cell, not a multi-cell, is 40 acres. I have also been involved with and aware of some feasibility studies for floating covers that were 80 acres and one up to 160 acres. So 40 acres is certainly obtainable and achievable. It's been done successfully, but that's not to say that would be the maximum. I think probably the most important issue, or the better question to ask, is when you're with your owner, if he's got a massive reservoir, is the floating cover will need replacement at some point in time, whether it be 10 years, 20 years, 30 years. Really the question is, if that's a large body of water, single body of water for the owner, how will he address his operations, say 30 years from now, when he has to take that reservoir out of service to replace the floating cover? And then a lot of times then the owner starts thinking, and he realizes that maybe he'd be better served having 3 smaller reservoirs than 1 larger reservoir. Practically, I think you could go probably up to 100 acres relatively confidently, but there are some other operational issues that I think are more telling.
Okay. Doug, again, how do floating cover systems compare to bird balls when using the tension membrane system with troughs to collect rainwater? Is a slope formed in the trough to help with collection, or do you allow some water to remain that the dewatering sump cannot efficiently access? Are these systems easily repaired if there is vandalism?
Well, that's a couple questions all wrapped into one. So the selection of the cover system depends on what the intended application is. And this can vary from, if you're looking for an evaporation cover, you're trying to limit exposure to sunlight, maintain heat for biological processes like in the MIC covers, protect the pond contents from wind-driven sediment and animal contaminants such as potable water, reduce chemical demand, collect gases. There's a whole variety of different reasons why you would put a floating cover or some of these systems in. The systems can range from bird balls, as they mentioned, to floating discs, to modular covers, or a full geomembrane floating cover. And not all of these systems would cover the pond contents, but they may be less costly, but may also be more limited in their capabilities. For example, bird balls isn't going to prevent animal contamination or wind-driven contamination into getting into the water. They may provide some protection for UV exposure and help maintain some chemical content inside the reservoir. Bird balls aren't going to provide much in terms of insulation as well. So it really varies in terms of what your objectives are in terms of what type of system you're talking about. To address the sloping troughs, a trough on the side slopes will be sloping just because of the way the cover is installed when the reservoir is empty. If the floor has a mild slope, then there would also be a mild slope of the rainwater collection trough. If your slope is perfect, if your floor is perfectly flat, then your rainwater collection trough parallel to the toe slope is going to be perfectly flat. The way the water is removed from the troughs is as the pumps come on, they draw down the water, and the water will seek the low point, and it'll continue to flow towards the pump. Keep in mind that if you have a trough hanging in the water, you have hydrostatic pressure from the floating cover underside, and that will squeeze the trough closed, thereby pushing the water towards the void space, which happens to be where the pumps are. So that's probably the best way to remove the rainwater, is that hydrostatic pressure directing water towards the void. There's differences in sump designs, and they can have different effectiveness in terms of removing rainwater and to what depths they remove rainwater. And then the last part of the question was, about repairability. Really, all these systems can be repaired with differing degrees of effort. I think repairability is more a function of what is the damage? Is it pinholes? Is it a tear? Is it a significant vandalism? All those can further complicate the repairability. But then you also have the age of material and surface cleaning and oxidation that may have occurred. But realistically, backing away from this, in most cases, repairs can be performed. I've known very, very few cases where repairs have not been successfully performed, and it was mainly with significantly old material that may have gone through a fire or something where there was just too many repairs to make it feasible to repair an old floating cover.
Okay. Hey, Doug, can you quickly describe a bird ball for all of our users?
Bird ball is a HDPE ball. I mean, simplistically, it's you go to some of the fast food places pre-COVID, and they had the kiddie play parks, and they had balls where the kids would jump in. Something very similar to that. They're HDPE balls, air-filled, and they are basically dumped into the cover or into the reservoir, and the balls themselves will distribute themselves out on the water surface. They're filled with air, so they'll naturally want to float. And they will not protect the pond contents from rainwater or debris or animals in all cases, but it is very effective in terms of limiting the UV exposure. And so they have a limited use, but in certain fields, they can be quite successful.
Okay. Next question for Brian. For the cable system, is there an issue with cracking or failure? It looks like a lot of pressure or stress that would require additional maintenance and or repair.
And I think, Tim, I probably have already answered that. I will just say again that, just from looking through our history of installing detention cable systems and the fasteners, quite surprising. We've had very little problems. They've been quite low maintenance. We do look at a lot of criteria, the size and configuration of the reservoir to determine whether the tension cable system is suitable in that application. We look at the freeboard fluctuation and frequency. We look at the weight and density of the material that's being used, the mechanical strengths of the materials. And certainly with all of that, we make sure, that we really look at the engineering in terms of the tensile pull-out strengths on the tabs and reinforced edges, etc. But, I think the designs have been pretty good because just, again, we've had very little problem with cracking and tearing. But I always continue to state with any floating cover, owners should try to make sure that, once a year or every second year, they're on top of the covers with planned inspection and maintenance programs, and everything seems to run pretty smoothly when they do that.
Okay, last question from the post-webinar survey form. How/where is the drainage installed on a lagoon cover? So maybe Doug or Brian, can you handle that?
Not quite sure I understand the question, but in terms
I'm not sure what they mean by lagoon cover.
Yeah. So if it's one of these, again, municipal secondary aeration systems, these are typically gravity fed, and at they could be multiple lagoons, and typically at the last lagoon, they will be discharging. They can, at this point, if they're meeting their discharge designs and permit requirements, they can be discharging into a field, they can be discharging into another waterway, quite strictly enforced again by the Clean Water Act, and state regulatory departments. So, you know, I do see, again, on these municipal aerobic secondary treatment, some of the ones I've seen through the Midwest, et cetera, you know, they are, they are discharging the final sediment ponds into fields or waterways, but they're fully meeting regulatory requirements at that point.
Okay. Doug, anything to add on lagoon covers, or we're good?
No, I think Brian covered it well.
Okay. So I'd like to thank Brian, Doug, and Rohit for joining us again and answering all these questions. If you have additional questions or would like additional information about floating covers, please send your questions to Brian Fraser at brian.fraser@layfieldgroup.com, and he will distribute the questions to Doug and Rohit as needed. Or you can download the webinar slides because their email addresses are on slide number 54. And the webinar slides can be downloaded from the resources menu on the FGI website, where the webinar will be posted, as well as this podcast. So Doug, Brian, and Rohit, thanks again for answering all these questions and your excellent webinar on floating cover systems.
Thank you.
Thank you very much.